So if the system is easier to tune, so the performance is, how to say that, can be predicted much more easily.
The last one.
Oh, the last one. Okay, so do you have any other answers? Do you all agree with the last one? Okay, so yeah. The crowd knowledge is the best, right? So the last one is our proposed method. It has better robustness in this case when we mean that the system tuning is easier. And also the performance of the system can be predicted more easily than others. In other cases, the system performance is very sensitive to the parameters, even in a small local region. So yeah, that's the conclusion about the robustness.
So for the last one, actually everything else are quite consistent, but in this region it's also kind of
yes, right. Yeah, exactly. And that part is very sensitive because we have very little number of training samples here. That confirms another assumption of our approach. The knowledge scope in this part is very small. So when we have a small knowledge scope, the performance will depend on what exactly knowledge do you have in that small knowledge scope. So it's not really robust. When we have a relatively large knowledge scope, it can roughly, how to say that, cover the unseen user queries information need. So in that case, it's very safe.
So here is this training sample. And then what is the K?
K is the small k. Oh, yeah, right. K is in this algorithm. If we didn't talk about details, I go back to the algorithm description, so we know what k is. Here you will see that in the offline case, it's an iterative algorithm. So it has t iterations. In each iteration, we will randomly choose a set from the whole training set to form a local, how to say that, an iterative training set. This set, the size is k, so that we may choose different number of training samples for each iteration. Because right here, so we can see whether the k matters in training the system. That's another property of this algorithm. You see, when the k is very small, that means when k equals to 1, that means in every iteration, we just choose one sample, even among a very large training set to train the system. The performance is still good. So, which means, so that confirms the very efficient property of this algorithm. The number of iterations has a certain property, which is dependent only on the training accuracy. So in this case, we can say that the number of iterations is fixed because it only depends on training accuracy, and the k doesn't matter that much.
So in the paper, basically you put the effectiveness, efficiency, and robustness.
Yeah, right.
So these three results is presented.
Yeah, right. That's the conclusion about this paper. Here is the conclusion. So we tried to improve two aspects of the multimodal fusion approaches. We used we use folksonomy to construct social queries to train the system, and we used the online regression model to derive the fusion weights. And we evaluated the system in multimodal music search scenario, which is different from previous research. And the philosophy of this, of all these proposals, I think can be easily extended to text and video, image search, and other search domains. If we really have the resource of video search, we can very easily do some experiments on that. So yeah, that proves the extendability of the algorithms. That's all.
I mean, the YouTube, most of these music pieces there are associated with video as well.
Right.
We have not utilized this video modality.
Yeah, when I say video resource, and not only video data, but also the video search engine, we need to build video feature extractors and video search indexing modules and something. That's quite time consuming. There is no open source yet we can implement. There is an open source text retrieval search engine we can use.
Okay. Do you think we can borrow some source code from the other group here?
Yeah, that would be perfect if they give us the source code.
Okay.
Yeah.
So nice presentation, and I have to escape.
Okay,
because
thank
I'm
you.
not yet.
Wish you a nice trip.
Thank you very much. Okay. Maybe you can finish out this recording.